Welcome to another CATIA V5 video. This will be regarding lathe machining. So this will be the case study part, and as you can see, we're going to have a rough turning, a profile finish for that, and also a groove turning and finish. So let me start the simulation so we see exactly where we're going to end up at the end of this video. So this is a simulation. As we can see, we're going to have those operations, and afterwards we're going to obtain this part. So I decided to create the lathe machining video since the other two videos that I created for prismatic machining basics and surface machining basics have quite a lot of views compared to other videos for CATIA V5, as you can see. So this will be the lathe machining basics. So let's get started from scratch. So this will be the design part. I'm gonna go to start mechanical design, part design, because this is a starting point for this. And over here, I will jump within the Y and Z plane. And we're gonna draw a sketch over here. So since this will be a revolve element, let me see if the screen is recording. So yeah, everything is fine. I will go with the profile tool and I will roughly create the profile that the part will have. So over here, we're going to have that groove. I see that that is not vertical, but I'm going to fix that in a moment. And afterwards, we're going to have an angle and we're going to close the sketch over here on the vertical axis. So I see that this is not vertical, so I will go over here and make it vertical. And now I will add the dimensions. I will double click on the constraint, so this will work a little bit faster. I will add the value 165. As you can see, since CATIA is an order software, if I would do the same within Solid, the first dimension that you add will automatically adjust everything. Over here, I will need to change a little bit the sketch position in order to compensate for that. So this is something that I find a little bit let's say not optimal within CATIA, but we're gonna change that. We see over here that we still have an overlay. So this sketch was upside down. So this is quite annoying, but we can work with that. Probably the newer 3D experience doesn't have this issue. I will also start to create content for that within the near future. So let's add all those dimensions, 20 millimeters. I will also make this 10. Afterwards, we can add that angle. So this will be an angle of 50 over here. And the diameter for the part will be 50 over here. So that will be the radius, this will be revolved. And also we're gonna have the top segment. So this will be 75. And all the sketch should, let's say, jump within the desired profile. So I will zoom in over here a bit. If you want to follow along, I highly encourage you to do that, so that you will not only check the video, but you will also attempt to recreate this on your own. So this will be the part. I will go afterwards to shaft. And for the axis, I will choose the horizontal axis. So this will be the design part. Therefore, within machining, it is best, let's say, a best case study and an optimal workflow to use different body names. So this will be the design part. And afterwards, I will create a new body, and this will be the stock. So I will go to properties and I will call this stock. And now we're going to define the stock profile. So this again will be a shafted profile. I will start from the same Y and Z plane. I will do a sketch. I can start directly with a rectangle. And I will add the same length. So for the stock 165 over here. And I will make the stock diameter a little bit higher in this case. It could be directly 50, and afterwards we won't have so much to machine over here, but I will leave it like this, so we're gonna machine that section as well. With this sketch, I will go and have this shafted as well along the that axis. Now I usually prefer to change the color of the parts. So for the stock, I will make this yellow, and I will also add transparency to better visualize the design part and also the stock. And now for lathe machining, it is important to highlight the sketches so that it will be easier to have those selected. So that means within the stock, I will hide the shaft, but I will reveal, so I will show the sketch underneath. So this will be the stock sketch, because within lathe machining, we are not gonna select bodies like we did previously. We are gonna select directly lines on the sketch. And for the design part, I will also show the sketch one over here. So we see that sketch and we see the other one. Okay, so everything is set. We can now go within the machining workbench. So go up to start machining, lathe machining. And we have the part operation over here. So I will double click on that. We see that there is no machine selected. I will click on the machine button, and CATIA will suggest a horizontal lathe machine. In this case, how we position the part, this will be fine. We're also going to have the spindle and the radial axis. I will leave them over here like this by default, but we're going to see that we're going to need to have those changed and adjusted. So I'll click OK. Afterwards, I will also change the origin. So currently the origin is over here. I will move it, so I will select the point and I will move the origin over here. Afterwards, we have the design part. So this will be the same like within the other two machining videos. So we need to select the part body. I expanded the product list, part 1, and I will double click on the design part. I will do the same for the stock over here. And now we see that the tool change point will be positioned over there. So I'm going to move the z-axis to be over here. So where we currently have the y-axis. I will go to the origin. And we see that within lathe machining, we can only adjust the x and the z-axis. So I will select the z-axis and I will make it go along the horizontal axis. Afterwards, I will click OK. Therefore, we're going to have the tool change point set over here, because by default, this is set to 100 millimeters over here. So this will be, but we're still going to need to address the axis. So we have over here the radial axis is currently not well defined. This should go on this direction, on the vertical axis, but we're going to change this later on when CATIA will notify us that the axis is not properly defined. So we have that defined. We can now proceed with the first operation. So I will select the manufacturing program over here. And the first operation will be the rough turning operation, which will have the following dialog box. So we have over here, we can define also an offset. For this case study, we are not going to add an offset for this. So we're going to go all the way to 0, and afterwards you're going to go with the finishing profile. But we're going to see how CATIA will visually change that, even though it goes all the way to 0. Since this is a rough turning operation, the surface will look a little bit rough, so it will not be smooth. Now, for the profile over here, for the stock, I will select the top segment over here out of that. And afterwards, for the part, if I will try to select over here, I see that the stock sketch is overlapping the other one. So I will just hide this for now. So sketch 2, I will have that hidden. So I can now properly select the part design revolve profile. So that will be the selection. At the end, you can go over here, you can click on OK, and you can double click somewhere on the background. That will also do that selection. And let's see, we see that we still have with yellow this section over here. So this will be for the tool. We are going to use an external insert holder for this operation. So I'll leave this as it is. Also, the feed rate is currently set to automatic compute, also for the spindle. I will leave them as it is by default, and afterwards we're gonna slightly adjust those. So I'll go to the toolpath replay, and we see that we have that error. So the problem is that we don't have properly set the radial axis. So our part goes over here, but the axis for the X goes on that direction. So in order to change that, we just need to go back to the part operation. We have over here the axis, and the x-axis should go on the vertical direction. And afterwards, click OK. Now, within the manufacturing program, the rough turning operation has remained, but this is not computed. So that means I need to go over here, and I will need to have this computed. And as we can see from the tool change point, which is located by default at 100 millimeters over here, you can change that within the part operation depending on the device. As we can see, the home position will be visible over there. So on the z-axis in this case at 100 millimeters. We have the total time for this 16 minutes. So this is quite a long time for a lathe operation. As you can see, the feed rate is only set to 0.8 millimeters per turn. But we're gonna change that. I'm gonna go within the simulation. We see that for surface machining and prismatic machining, we had the possibility to go for the photo view. But within lathe machining, we don't have that. We just have the video preview. And if I'm gonna click on that, we're gonna see how the lathe machine will look. Over here, we're gonna have this, let's say, stair profile. So this is not according to the offset dimension because we went with 0, but CATIA will show those visually, even though the geometry will not be over there. So this white lathe machine is not that well defined, such as surface and prismatic. Those are more, let's say, they have more functionality. Over there we have the possibility to go with photo, to click on those and see exactly what is the normal deviation in each point. So we have the rough turning operation done over here. I will click OK. We're going to see that this will be computed. Now let's do the following operation, which will be the groove turning for this section over here. So have the last operation selected. The rough turning should be in orange over here. That means that this will be selected. And now if I'm going to click on the following operation, the groove turning, this will go underneath, so after that. And for the selection, we're going to have the profile of the offset of the stock. So of the stock over here, double click on that. This will be the stock element. Afterwards, we're going to do the selection for the groove. So that means we only have to select those 3 segments that define the groove. Again, I will go with the offset to 0, even though this is the groove turning, so this is not the finished operation. And some of the changes that we need to do will be for the tool. Now that I see this, I remember that we didn't change the feed rates, so the previous operation takes 16 minutes, so we're gonna have that changed. Let's go over here within the tool, and since this is an internal groove, we're gonna need to change this. We're gonna go with the first option over here, so this will be the groove external insert holder. And for the, we can also change the profile of the inset over here. So we can either go with a groove inset, or we can go with a trigon for this. I will select the trigon, and I will make this smaller. So this length, I will double click on this, and I will make this 2 millimeters long, so that will make the overall trigon inset a lot smaller. I will keep the same radius, so within the description over here. I will go to the feed rate and I will have those slightly adjusted. Let me just check some of the settings for this. So I will change the lead in to be 1. For the first plunge, I will leave it like that. Next will be again 1 millimeter per turn. I will disable the automatic spindle. And I can slightly increase this. So the machining will be at a higher rate. 1500 over here. And yeah, we can leave the rest as it is. And I will go and have that. So we're going to see that the total time will be 11 seconds for this one. If I will go and do the replay, we're going to see initially we're going to have the first operation, the turning, and afterwards we're going to have the grooving. Again, this surface will be quite, let's say, wavy with ups and downs, because CATIA knows that this is a groove turning operation. Even though I set the offset to 0, it will look like that over there. So we see that the stock offset and part is set to 0 for this case. Now, we see that those two are computed, but I want to adjust the feed rate for the first operation because it was set automatically and it took 60 minutes for this. So let's change that. Jump over here, disable the automatic and add 1 millimeter for the lead in. For the plunge, the plunge will remain 0.3 since that is not open. But for the lift off machining, have that set to 1 and change over here the spindle output to 1500 over here as well. And if I will simulate this again, we're going to see that this will now take 19 seconds. And again, we have the possibility to visualize that. So this will only show us the turning, but if I'm going to go all the way to groove, it will show both of those. So with those two operations computed, we can now go and do the finishing operations. So for the finish operation, we're going to see that for the profile, we're going to have it over here. So after the groove turning, or since it's the groove, let's do the groove finishing operation first and afterwards for the turning. So let's search for the groove finishing. It should be over here. So this is a groove finishing. We're going to select that profile. So as you can see, we don't have any changes to do to the stock. This will be only regarding the part. We have the same tool for this one. And yeah, I'm just going to leave it like this. It will be done using the same trigon inset over here. So this will mainly just change the visual because in reality it does the same just like within the previous one. But as we saw over here, if I'm going to play this forward, we have the operation and afterwards we're going to have that finishing profile. And we're going to do the same now for the whole profile of the part, since this the looks will change for that visually. So having the groove finishing selected, I'm going to go to the profile turning, so which is this one, profile finish turning, because it's a finishing operation. And we're going to have to select the profile over here. I have the possibility to hide that. I could choose only that profile over here, but I will also add those two segments that will connect to the origin within the shaft. So this one and that one. It won't do any harm for this. So now for the tool, since this will be a finishing operation for the turning, we're gonna need to go back to an external inset holder for this one. This will be tool change number 3, and I will leave this to be a trigon inset. I can also change it, let's say, as a case study, I will go with a diamond inset for this one. For the feed rate, I will leave it like this with automatic. I will just disable the automatic spindle so that it will take that, even though we see that the value remained over there. So let's go to that. And we see that the profile over there, the diamond insert for that. And we can do the simulation of the operation. We can also change the speed for this. So if I'm gonna move all the way over here, it will be faster. If I will go somewhere, this will be the slowest speed over here. So let's do that toolpath replay, and we're gonna see how those finishing operations will look. Now over here we have a little bit with yellow and some with green, but those are quite within the same nominal value. As you can see, we can do the pick point. So within the other machining workbenches in CATIA, we could go directly within photo and we could click those. We have the possibility to do the same over here directly within the simulation view. And we're gonna see that wall thickness will be, let's say, the equivalent of that nominal value. But if you saw my last video regarding measure between and how you can measure some elements within CATIA, you know that for Evolve, the measurement tool doesn't work that well. So let me see if I have that video over here, because if you are curious to learn how you can measure in CATIA, this is a video. So how to use the measure tools in CATIA. I will put a link within the video description. And if you're gonna check this, you will know that for Evolve parts, the measurement tool in CATIA is not that great. Also, it has some slight deviation for revolve parts and mainly for circular components. So there are some slight changes to the value that over there. Okay, so overall, this was the basic regarding lathe machining. I will also position a similar video over here to the left, and I will add this to the CATIA V5 tips and tricks playlist, and I will also add a subscribe button over here to the right. So consider to either leave me a comment or subscribe if you enjoy this kind of content. And yeah, that's it. So thanks for watching.